is find the value of c that will make the function continuous at x equal to 3. So just looking at this, and c is a constant, right? Looking at this function, it seems like this part is one piece of this piecewise defined function is a linear function. The other piece is a rational function. And rational functions are continuous on their domain, linear functions are continuous in the domain, but this function is restricting the domain of both of those pieces, basically. So each piece is continuous on its domain. That means that this piece has a discontinuity at x equal to 0, and this piece has no discontinuity on the interval 3 and infinity, not including 3. And so what we're saying is that each piece is, but the part that they are pieced together may not be continuous. So when you have a piecewise defined function, you can find the domain of each piece and intersect it with the domain, the restriction of the piecewise defined, and that would be all continuous within that, and then you have to check the cutoff points where the two pieces are pieced together. So let's go to the link and watch both. So this actually gives you a little chance to look at the two pieces. One piece, remember, the first piece to the left of 3 was piecewise defined, and it was a rational. To the left of the piecewise defined function, is a rational function, and then the other piece is a linear function. But the linear function has a constant that is c, and c can change, and so basically you can bring the linear line up or down, that little piece of the line up and down, and at some point I can't quite be precise, but at some points they become connected to each other. So we're trying to find that point that it becomes connected, and I can't quite, we have to make this a little bigger and make sure that that we're finding the right number, but it's approximately around 21 that is happening. So let's make sure that that's the value actually. So that's what we're doing. We're finding that c that connects these two pieces together, but we're explaining this in mathematical terms. And so back to here, and we're trying to basically find the value of c that makes these two be connected together, right? And what does that mean? That means that prediction that we're coming from right side and prediction that we're coming from the left side are equal to each other, equal to the value of the function. What is the value of the function? It uses the left values, left piece of the function, and so basically f at 3 is equal to 2 times 3 plus 9 over 3, which is 6 plus 3, 9. Now, what in the other part is that I have to find limits as x approaches 3 from left side. What is to the left of 3? That would be this piece. So I'm finding that. Again, this is a continuous function, so I can basically plug in 3 into here. It's continuous at 3, so I can plug in 3 to find the limit. And so that would be equal to 9. And then the limit from the right side is, I have to use the piece that is to the right side of 3. That's x values are bigger than 3. So I have to find the limit of this. And again, this is a continuous function, so the limit within its domain is on its domain, so limit of any as x approaches any value within its domain is just plug in negative 4 times 3 plus c, and that is negative 12 plus c. So this value should be equal to this value equal to that value. In this case, these two are equal, so I don't have to worry about that. And so I just have to set 9 is equal to negative 12 plus c and solve to get c equal to 21. So c equal to 21, when we watched it on the app, that they actually, the two pieces are connected together if c is equal to 21. And this is what we get from the definition of the continuity as well. So if we want continuous at x equal to 3, that's the value that we have to use basically. And then for c equal to 21, the function is continuous everywhere but at x equal to 0.